let's look at the 4 problems that I assigned you for optimization. So this first one, you need 2 positive numbers. So we'll say the first positive number is x, and the second one is y, since we don't know what they are. The primary is that their sum is equal to the first plus 3 times the second. That's the optimization equation, the primary equation. That's the thing that we want to maximize. The problem is that it has 2 independent variables, x and y. So I need a secondary equation. It says that their product is 192. So I can use the secondary equation to solve for one of the variables, substitute that into the primary equation. Now it's all one variable. So now I can go find its maximum or its minimum. And I want the sum to be a minimum. So I'm going to simplify before I take the derivative. Let's see here. So it's 576, and we'll bring that x up. Now we can do the derivative. So now we want to set that equal to 0. Since there's a negative exponent, I'll bring that back down. Now that I have a rational function equaling 0, I need a common denominator. So when I combine, I want to find now where the top and the bottom both equal 0 to find our critical numbers. So that's at 0, and then the square root of 576 plus or minus, which is 24. Since they wanted 2 positive numbers, I don't have to test here because neither of those numbers are positive. I do have to confirm that this goes minus plus. It does. And that was x that I was solving for, as you can see here. So I know that x is 24, and to get y, I plug that back in to my secondary. And I get 8. Those are my 2 numbers, 24 and 8. All right, let's move on to 17. You've got a farmer that wants to build a fence next to a river. So we don't need fencing on the river side. We want to minimize the amount of fence. So that's going to be, we'll call it perimeter. We want to minimize it. X plus 2y. So we're going to need a secondary equation, and that is the area. 180,000 equals the area x times y. So if I solve that secondary, I get that. I make my substitution. I simplify. I take the derivative. I set it equal to 0 to find those critical numbers. I get my common denominator. My critical numbers are what make the top and the bottom 0. So that's 0 on the bottom, and the square root of 360,000. That's negative 600 and positive 600. Because we're talking about the length of the side of a fence, it's 600. If I plug in a number from this interval, it's a negative. From the other one, it's a positive. That makes 600 a minimum. So they want the dimensions. So 600 by, I have to plug this 600 back into my secondary. So 180,000 divided by 600 is 300. Number 18 is a similar problem, except this time the pen has 2 sections. They give you a picture. I'm going to fill in the other parts that I know. This time we know we have 200 feet of fencing, so that's our secondary. Our primary is the area, and we want to maximize it. The area is 2xy. I'll write the secondary down here. We have 200 feet of fence, and that is going to be 4x's plus 3y's. So we've got to solve that. I'll solve it for y. I make my substitution up here. Simplify. By distributing the 2x, I take the derivative. Yep, 16/3, and then I set equal to 0 and solve. This one's a linear equation, so I solve for x. I add 16/3 x to both sides. Then I multiply both sides by 3/16, and I get x equals 25. And then they want the other dimension that provides a maximum area, so I plug the 25 in to my secondary equation over here. So I'm plugging in 25, I get 100, so 200 thirds minus 100 thirds, 100 thirds. Okay, on 20 there's a box, a piece of paper that we're going to fold to make a box, so we cut out squares of x and then fold. The paper is 24 inches by 24 inches. That means this distance from here to here is actually 24 minus 2x, because you have an x on each side. And this distance is 24, I'll write it this way, inside 24 minus 2x. Alright, so when it folds up, so those dimensions are 24 minus 2x, and the height is x. So I want to maximize volume, so it's x times 24 minus 2x times 24 minus 2x. Take my derivative, it's product rule, so it's f prime times g plus f times g prime. So now I'm going to simplify. So I'm going to say that's a minus 4x when I multiply these guys together and put them out front. Then I'm going to common factor. Then I set equal to 0 and solve. So that's going to give me 2x, so I'm going to get 12. And the other one I'm going to get 4. I don't have to test 12 because 12 is outside the domain, because I won't have any paper left if I cut squares of 12 inches. So then I plug in, I get a positive, I get a negative. So when x is 4, the volume is a max. What did they ask? They said verify them, and also use calculus to find critical number and find the maximum value. So when x is 4, the volume is the max. If they want the volume, it's 1024. I plug it back into my volume equation.